Good morning students, welcome back. This is Dr. B. Thulasi, working as Associate Professor in the Department of Computer Science and Engineering, VNITSW Institute of Technology and Sciences for Women, Palakaluru. In the last session, we have seen second unit. The contents of the second unit are the classes and objects, the nature of the object, relationship among objects, nature of class, relationship among classes, interplay of classes and objects, identifying the classes and objects, importance of classification, key abstractions and mechanisms. These are the topics which we have covered in the Unit 2. And in today's session, we are going to discuss the Unit 3. And the contents of the Unit 3 are Introduction to UML, Why we model, Conceptual model of the UML, Architecture, Classes, Relationships, Common mechanisms, Class diagrams and Object diagrams. And coming to the session, let's start the basics of the unit as usual. Let me start with the question, what is UML? And the name says it's all. UML stands for the Unified Modeling Language. Unified Modeling Language is an open standard graphical notation for system development proposed by Object Management Group. Object Management Group is a consortium of software. The notation is based on work from Grady Buch, James Ramba, Yvonne Jacobson. And UML is a modeling language to express and design documents, software particularly useful for the object-oriented designing. The language can be used from general initial design to very specific detailed design across the entire software development lifecycle. And Unified Modeling Language is a graphical language for modeling and developing of software systems. The UML diagram become a common work product for developers to use to discuss all the phases of the software development. We have seen in the first unit the phases of the software development, and the UML is used for all the phases in the software development. It means requirements gathering and analysis, design, implementation, testing, deployment and maintenance. The goal here is to model the software system before we build it. Unified Modeling Language is a modeling language that combines various approaches in a single design language, which is used to plan and create computer applications. UML is actually a combination of several notations. That means object-oriented design, object modeling technique, which is also known as OMT, and object-oriented software engineering, OOAD. The Unified Modeling Language is a family of graphical notations backed by a single meta model that help in describing and designing software systems, particularly software systems built using object-oriented style. It means by using OOPS concepts. Coming to the next topic, the architecture of the UML. Visualizing, specifying, constructing and documenting a software-intensive system demands that the system be viewed from a number of perspectives. Different stakeholders and users, analysts, developers, system integrators, testers, technical writers and project managers each bring different agendas to a project, and each looks at the system in different ways at different times over the project's life. A system architecture is perhaps the most important artifact that can be used to manage these different viewpoints and thus control the iterative and incremental development of a system throughout its life cycle. Next, the architecture is a set of significant decisions about the architecture of a software system, the selection of the structure elements and their interfaces by which the system is composed, and their behavior as specified in the collaborations among these elements, the composition of the structural and behavioral elements into progressively larger subsystems. The architectural style that guides this organization, the static and dynamic elements and their interfaces, their collaborations and their composition. Software architecture is not only concerned with the structure and behavior, but also with uses, functionality, performance, resilience, reuse, comprehensibility, economic and technology constraints, and trade-offs and aesthetic concerns. If you see the figure, it is having 5 views. Okay, so design view, implementation view, use case view, interaction view, deployment view. Let us see these all 5 views in detail. The architecture of a software intensive system can best be described by 5 interlocking views. Each view is a projection into the organization and structure of the system, focused on a particular aspect of the system. Here, let's see the views one by one. Coming to the first view, the use case view of a system encompasses the use cases that describe the behavior of the system as seen by its end users, analysts, and testers. This view does not really specify the organization of a software system. Rather, it exists to specify the forces that shape the system's architecture. With the UML, the static aspects of this view are captured in use case diagrams. The dynamic aspects of this view are captured in interaction diagrams. As I told you, interaction diagrams means state chart diagram, activity diagram. By using those type of diagrams, you can capture the dynamic aspects of the view. And next, the design view of a system encompasses the classes, interfaces, and collaborations that form the vocabulary of the problem and its solution. It means the name itself indicates design view. Design means it tells about the vocabulary of the problem and the solution, how we need to design the solution. This view primarily supports the functional requirements of the system, meaning the services that the system should provide to the end users. Here, every system will have some functional requirements and non-functional requirements. Coming to the functional requirements, the system should provide what the requirements of the end user. Non-functional requirements might be the reliability, usability of the system. Such type of factors will be considered as the non-functional requirements of the system. With the UML, the static aspects of this view are captured in class diagrams and object diagrams. The dynamic aspects of this view are captured in the interaction diagrams as usual. Static means we'll go with the class and object diagrams. Here interaction means as usual. As I told you that state chart diagrams and activity diagrams are the interaction diagrams. By using those, we can capture the dynamic view of the system. To represent this internal structure of a class is particularly useful to represent the internal structure of the view. The interaction view of a system shows the flow of control among its various parts, including possible concurrency and synchronization mechanisms. This view primarily addresses the performance, scalability, throughput of the system. These are nothing but the non-functional requirements of the system. With the UML, the static and dynamic aspects of this view are captured in the same kinds of diagrams as I told you in the design view. What are the static diagrams means? Those are nothing but the class diagrams and object diagrams. And to capture the dynamic view, we used to have the interaction diagrams such as state chart diagrams and the activity diagrams. But with a focus on the active classes that control the system and the messages that flow between them. And coming to the implementation view of a system encompasses the artifacts that are used to assemble and release the physical system. This view primarily addresses the configuration management of the system's releases made up of somewhat independent files that can be assembled in a various ways to produce a running system. It is also concerned with the mapping from logical classes and components to physical artifacts. With the UML, the static aspects of this view are captured in the artifact diagrams. The dynamic aspects of this view are captured in interaction diagrams like a state chart diagram and activity diagram. Coming to the next view, that is deployment view. The deployment view of a system encompasses the deployment means in the deployment diagram also we know that nodes are used. Nodes and relationships itself indicates the deployment diagrams. Here the deployment view of a system encompasses the nodes that form the system's hardware topology. Topology means layout of the structure or layout of the system on which the system executes. This view primarily addresses the distribution, delivery and installation of the parts that make up the physical system. Within the UML, the static aspects of this view are captured in deployment diagrams. The dynamic aspects of this view are captured in the interaction diagrams. As I told you, the state chart diagrams and the activity diagrams are the interaction diagrams. So by using the interaction, that there represents the dynamic view of a system. Each of these 5 views can stand alone so that different stakeholders can focus on the issues of the system's architecture that most concerns them. These 5 views also interact with one another. Nodes in the deployment view holds components in the implementation view that in turn represent the physical realization of classes, interfaces, collaborations, and the active classes form the design and process views. That means process view. For process view means we need to go for the active classes, which represents the thread of control. So that is the use of using this active classes. The UML permits you to express each of these 5 views. This is regarding the architecture of the UML. Here we are having 5 views. That is what we have discussed till now. Coming to the next topic, that is software development life cycle. Here, a software development process is a set of activities needed to transform a user's requirements into software system. What the user requires, that will be converted into the software system. The UML is largely process independent, meaning that it is not tied to any particular software development life cycle. However, to get the most benefit from the UML, you should consider a process that is use case driven, architecture-centric, iterative, and incremental. Use case driven means that use cases are used as a primary artifact. It means if you see the data driven means the data will be the primary artifact. Here, use case driven means that the use cases are used as a primary artifact for establishing the desired behavior of the system, for verifying and validating the system's architecture, for testing and for communicating among the stakeholders of the project. And coming to the architecture-centric means that a system architecture is used as a primary artifact for conceptualizing, constructing, managing, and evolving the systems under development. And iterative process, iterative, the name itself indicates iterative. Iterative process is one that involves managing a stream of executable releases. We'll go on releasing, we'll take the output from the users and we'll release the new version. This is nothing but the iterative process. An incremental process is one that involves the continuous integration of the system's architecture to produce these releases, with each new release embodying incremental improvements over the other. Together, an iterative and incremental process is risk-driven, meaning that each new release is focused on attacking and reducing the most significant risks to the success of the project, which are making the system to slow down. So we'll use this type of iterative and incremental process. This use case driven, architecture centric and iterative and incremental process can be broken down into phases. A phase is a span of time between two major milestones. Phase means it is a span of time between two major milestones of the process. When a well-defined set of objectives are met, artifacts are completed and decisions are made whether to move to the next phase or not. So this is regarding the, you can see the structure, software development life cycle. In this structure you can see the 4 phases. One is inception phase, elaboration phase, construction and transition. So here we are having some more processes. Those are business disciplines, business modeling, requirements, analysis and design, implementation, testing, deployment and supporting disciplines, configuration and change management, project management, environment. These are the different processes which we used in the software development life cycle. In the figure, the software development life cycle, you can see the phases. As I told you, there are inception phase, elaboration phase, construction and transition. In the diagram, we have seen the workflows also. I guess that these phases, these workflows of having varying degrees of focus over time. Coming to the first phase, that is inception phase. Inception is the first phase of the process, when the seed idea for the development is brought up to the point of being at least internally sufficient, well-founded to warrant entering into the elaboration phase. This means inception phase is nothing but the seed idea for that development. In this phase, the seed idea is brought into the development. Then that phase is nothing but the inception phase. Next one is elaboration phase. This is the second phase of the process. When the product requirements and architecture are defined. It means elaboration. The name itself indicates that is something elaborated. In this phase, the product requirements and architecture are defined. In this phase, the requirements are articulated, prioritized, baselined. A system's requirement may range from general vision statement to precise evaluation criteria, each specifying particular function or non-functional behavior and each providing a basis for testing. This is regarding the elaboration. Inception phase means seed idea. Elaboration means we'll elaborate the phase. It means we'll have some basic requirements and we'll prioritize, we'll baseline the requirements. We'll go for the designing also. Next one is construction. Construction is the third phase of the process. When the software is bought from an executable architectural baseline to being ready to a transitioned to user community. Here also the system requirements and especially its evaluation criteria are constantly re-examined against the business needs of the project and resources are allocated as appropriate to actively attack risk to the project. And means we'll come to the construction is nothing but the implementation phase. And in this phase, we'll constantly re-examine about the business needs and we'll go on the development. Next one is the last phase. That is nothing but the transition phase. Transition is the fourth phase of the process and the software is delivered to the user community. Rarely does the software development process end here. For even during this phase, the system is continuously improved. Bugs are eradicated and features that did not make an earlier release are added. It's just like the deployment phase and the maintenance phase. One element that distinguishes this process and that cuts across all the four phases is an iteration. An iteration is a distinct set of work tasks with a baseline plan and evaluation criteria that results in an executable system that can run, tested, evaluated. The executable system need not be released externally because the iteration yields an executable product. Progress can be judged and risks can be re-evaluated after each iteration. This means that the software development lifecycle can be characterized as involving a continuous stream of executable releases. Executable releases means we are going in an iterative phase of the system's architecture with a mid-course correction after each iteration to mitigate potential risk. It is this emphasis on architecture as an important artifact that drives the UML to focus on modeling the different views of the software architecture. This is regarding the architecture of the UML and the software development lifecycle. In the architecture, we have gone through the 5 views. In the software development lifecycle, we have seen the 4 phases. There are inception phase, elaboration phase, construction phase and transition phase. These are done in a iterative fashion to achieve the workflows of a system. This is regarding the software development lifecycle. We have covered all the topics of Unit 3 and let's have a quick recap what we have seen in this Unit 3. In this unit, we have discussed about what is UML. The UML is a language for visualizing, specifying, constructing documentation. Why use UML? What is the main purpose of using UML? What is a model? A model is a simplification of reality. Why do we model? And what UML is not? Objectives of the UML, history of the UML. We have seen the principles of the modeling. In that we have seen 4 points. Next we have seen the object-oriented modeling. The 2 most common ways are from an arithmetic perspective and from an object-oriented perspective. That's what we have discussed here. A conceptual model of the UML. Here we have discussed about the building blocks of the UML. In the building blocks of the UML, we have seen the vocabulary of the UML encompasses 3 kinds of building blocks. Those are things, relationships and diagrams. And coming to the conceptual model, we have seen the building blocks and the rules and common mechanisms. We have seen the architecture of the YAML, and this we have seen about the 5 views of the architecture. And next we have seen the software development lifecycle, and this we have seen about the 4 phases: inception, elaboration, construction and transition. And we have seen about the workflows also. Next we have seen the classes. In the classes we have seen about the attributes, operations and responsibilities. Coming to the common modeling techniques of the classes, we have seen the how to model the vocabulary of a system, how to model the distribution of responsibilities in a system, and modeling non-software things, modeling primitive types. This is what we have discussed in the classes. Next we have seen the relationships. In the relationships we have discussed about the dependency, generalization and association relationships. And we have seen the common modeling techniques. In the common modeling techniques we have seen about the modeling simple dependencies, modeling single inheritance, modeling structural relationships and creating web of relationships. This is what we have discussed in the relationships chapter. And coming to the common mechanisms, in this we have discussed about the nodes, stereotypes, tagged values and constraints. So in the common modeling techniques we have seen about the how to model the comments, how to model new building blocks, how to model new properties, how to model new semantics. This is what we have discussed in the common mechanisms. Next we have seen the class diagrams. In the class diagrams we have seen the what is a class diagram, and in the common modeling techniques we have seen the how to model the simple collaborations, how to model the logical database schema, and what is forward engineering and what is the reverse engineering, how our tools are supporting, and is our code supporting or not for the model which we have generated. Next we have seen the object diagrams. In the object diagrams we have seen about what is an object diagram, and next in the common modeling techniques we have seen to model the object structure. Next we have seen the same what we have studied in the class diagrams also, that is nothing but forward and reverse engineering. For all these chapters we have seen the tips we need to follow while modeling a system. And coming to the next part, which is very interesting part, that is quiz. So in the quiz, what type of relationship is represented by shape, class and square? If you see the figure, it is having 4 options: realization, generalization, aggregation and dependency. So find out the answer. If you see it clearly, you can see as generalization. Next one is, which diagram in YAML shows a complete or partial view of the structure of a model system at a specified time? So here we are having 4 types of diagrams: sequence diagram, collaboration diagram, class diagram, object diagram. For this specified time, it means instance. For instance, we need to use this object diagram. Which of the following is the building block of YAML? So coming to this, things, relationship, diagrams, all of the mentioned. We know that conceptual model of the YAML consists of building blocks of the YAML, rules and common mechanisms. Coming to the building blocks, here we are having things, relationships and diagrams. So the answer is all of the mentioned. Next, classes and interfaces are part of structural things, behavioral things, grouping things, annotational things. The answer is structural things. What is the physical element that exists at runtime in YAML? The options are node, interface and activity, none of them mentioned. The answer is node. Which things are dynamic parts of YAML models? Structural, behavioral, grouping things, annotational things. So, dynamic parts represents the behavioral things. Which of the following term is best defined by the statement? A structural relationship that specifies the objects of one thing are connected to the objects of another. This is association, aggregation, realization and generalization. We know that the semantic relationship is done by using association. Aggregation represents the whole part and realization is the collaboration property, and generalization means it represents the superclass and subclass relationship. So here the semantic relationship is nothing but the association. So coming to the next one, object-oriented analysis and design can be handled by one who knows YAML. So if we know the YAML, we can handle object-oriented analysis and design? No. The option is, we are given true and false. The correct answer is false. At conceptual level, class diagram should include operations, attributes, both operations and attributes, none of the mentioned. At the conceptual level, it is enough to have attributes only. Next, what is an object? We all know that object is an instance of class. An object includes encapsulation of data. An object is not an instance of class, all the mentioned. So, object is an instance of class. UML interfaces are used to specify required services for types of objects and program in Java but not in C, C++ or Smalltalk. Define executable logic to reuse across classes. Define the API for all classes. The answer is specify required services for types of objects. And next, how many diagrams are there in Unified Modeling Language? 6, 7, 8, 9. So the option is 9. What are they? Class diagram, object diagram, use case diagram, collaboration diagram, sequence diagram, state chart diagram, activity diagram, component diagram, and deployment diagram. So we are having 9 diagrams. What are the common mechanisms of object diagram? So object diagram is used to represent the object structure. So before I giving answer, if you can answer these questions, I think you understood the class well. If you have any doubts, go back and play the videos. If you think that I'm going a little bit fast, don't worry. Then play the video slowly. It means, hope you people know how to play the video slowly. So if you don't know, I'll give you an idea. Just go to the settings in the YouTube. Click on the settings. You'll have a playback speed. You'll have an option known as playback speed. In that you'll be having normal and 1.25, 1.5. If you want to go slow, then go for 0.75, 0.5. If you want to go fast, then go for 1.25, 1.5. So by doing this, you can customize the speed according to your need. So thank you so much. Let's meet in the next session. Till then, have a safe day. Follow SMS. As usual, sanitizers, masks and social distancing till we get the vaccine for the corona. Stay safe, stay healthy. Thank you.